edge routers that use default routes quite a bit. They just know how to route to their close by places, and then they have a default entry that goes in. This is a big overhead. And I will talk about how you might sort of relax the security it offers just to be more practical. Very good question.
Yeah, I don't see why, I mean, it's one entry per fifth entry, so why did you imply that there's something subtle to it about scalability? Is there something we're missing? It looks like finite in size and small enough.
It's finite, but you don't.
The updatability of it?
It's finite. It's about 200,000 entry, and you keep it for everyone. The deployment status, this is partially deployed. That's what the assumption is. So while going towards the destination, you need to know whether there's at least one deploying router along the way or not. So if you see any, you just put a 1. Similarly, the markings, whichever path the packet takes to come to you, you only care about the last deploying router in that path just before it hits you and what marking they are using. So even though you're storing marking information for every prefix, but it might be repeated actually here. For example, if all of East Coast is coming to you via this particular router, then you're storing it for every prefix, but you're storing just one entry. Yeah. So the question now is, yes.
I wanted to go back to the table. And
Okay.
You said that those markings are supposed to be secret, but if you store a lot of them, just like if you get information from a couple of major routers, it looks like, I mean, you might be set for the entire internet. You learn the markings, for most of the routers.
That's why it's important to not have the routers compromised in this. If your routers can't be trusted, if your end host cannot be trusted, that we are assuming, but if your routers cannot be trusted, then this would be hard. I don't know whether we will have the chance to get to it or not. The markings do change often. Like you might change them every 20-30 minutes, and of course every time you change marking there has to be issues of how the new markings propagate in the routing tables have to be addressed. So you want to keep the overheads low, at the same time keep the markings secure. But in general, yes, if you manage to compromise a backbone router that has all the markings for the neighbors, then it is a problem. In general, you cannot afford to have routers compromised. And again, the reasoning for not addressing that issue is the same as, well, if your routing itself could be wrong in the first place, if the router is bad,
right,
then the packets won't get routed. They route the packets wherever they want.
But it also will depend on how they broadcast that marking information to all other routers, right? If it's incorporated into an existing protocol, that's not secure, that it's going to be a problem.
Yes, if you compromise a major router, and you compromise in the sense even when the router markings are updated, you get the new markings. And then, of course, this router will tell any end host on the internet as to what the markings of the neighboring routers are. I do have some simulation results here that show that because these markings, even though there's one marking for every prefix, however, every router is learning markings only of routers in its vicinity. And markings are per interface, as in if you're using multiple paths, then markings will be different. Which means that even if you learn the markings, you have to be coming on the right interface to exploit the markings. And our results actually show that unless the entire internet host know about the markings, even if a router is compromised, you actually cannot misuse the markings as much as you would think. So, but that's a very good question, and hopefully I'll get to the simulation results, and you'll see that for perfect security, yes, learning any marking is bad, and our scheme doesn't prevent any markings from being learned. However, for practical spoofing prevention, many of such cases will get blocked out, because even if you know the marking, someone knows that marking cannot come that way. They just drop it. Make sense? Okay. So notice that earlier A router would just do one lookup. It looks at the destination, it looks up this table and says this is the interface it would go. Now I've put two arrows here, which means that for the source address you do a lookup, for the destination address you do a lookup. So which means that if your router is a gigabit per second router, it actually is getting gigabit per second traffic. In this scheme, its throughput would become half. So half of the traffic will probably get dropped or delayed. Okay? It does require an extra lookup for each packet. So that's the overhead and that's the cost you have to pay. Now the question is, it's good that we have these markings in the table, but how do we learn the deployment status and markings? How do these fib tables get populated? That's the question. One way is you have some sort of a key exchange protocol where the routers go to either this, like an infrastructure of some sort, and it exists. You just go to the infrastructure and say, what's the marking of my neighbor? And there is some authentication that goes on and you learn their markings. However, that means that you cannot really deploy that solution immediately. If your focus is on practical solution that can be immediately deployed, then that approach will prevent you from doing that. So here are the approaches that can be used and that can be used instead. So the first approach we use is to tag along the marking and deployment and status along the BGP route announcements. So everyone here is familiar with BGP? Border Gateway Protocol for inter-domain routing information. So this protocol essentially tells you for this prefix, for this destination prefix, the packet should go, come from this path, right? And path meaning a domain or an autonomous system. In that, you can actually put the markings for, if a network generates a BGP route announcements and is deploying, it can put its marking and says, oh, I'm deploying, right? And this announcement will propagate in the internet and everyone would know about the routing. However, there are some issues to consider. One is BGP route announcements are often suppressed, which means an edge domain doesn't see all the announcements because the core router or the other routers they're connected to, sometimes their policies prevent these route announcements from propagating further. So at the edge, you don't see all the announcement. And that's part of the reason why the edge routers actually contain a few IP addresses there where they can actually route to. Beyond that, there's a default entry where they just send all the rest of the traffic there. Right? So you can learn markings in general through BGP route announcements, but only the core routers will be able to do it. Most likely the edge routers will not be able to learn them. Right? And as the announcements are propagating, you can say that okay, I'm the deploying router, so even though it's for the same prefix, use my marking. And that's how a router only maintains markings about its neighbors, not about the actual deploying one. So you contain damages in some way. The other problem is asymmetry. Yeah.
What if my neighbors don't deploy this marking scheme? So
when I say neighbor here, this is just the deploying neighbor.
Okay.
So you may be directly connected to two other routers, and then a third router is deploying. But that third router will say, okay, for this prefix, use my marking, and there is a deploying one. And the legacy routers, they just ignore these extra. You can think of them as options in a BGP route announcement. So whenever I mention neighbor, it's the neighbor in terms of the deploying router.
Okay. So that if, for example, I'm just a company, right, and I always go through the same internet provider, and I have to keep just one router in my table because this is the only path to the internet. But if that router is not deploying this marking scheme, then I have to give information about others, right, that are farther away from me.
Okay. So I think that this point probably didn't come across from what I just said. If you are connected to a router and your router isn't deploying it,